Welcome to the DIY Honda Garage channel. Welcome to the diagnostic overview for DTC P2185, which stands for Engine Coolant Temperature ECT Sensor 2 Circuit High Voltage, specifically for the Honda Civic models from 2006 to 2011. Understanding this error code is essential because it relates to the ECT sensor's ability to accurately detect coolant temperature, a critical factor for engine performance. The ECT sensor plays a vital role by providing real-time data to the Engine Control Module (ECM) or Powertrain Control Module (PCM) regarding the engine's temperature. This data is then used to adjust fuel injection and ignition timing accordingly to optimize engine efficiency. Incorrect readings, such as those indicated by a high voltage or extreme temperature readings, can lead to engine performance issues, including rough idling, poor fuel economy, and increased emissions. Therefore, addressing this issue promptly is crucial for maintaining the vehicle's functionality and minimizing potential engine damage. DTC P2185 signals a problem specifically with the ECT Sensor 2, which measures the coolant temperature to inform the engine management system. The ECT sensor is typically located near the thermostat housing in the engine bay, making it relatively accessible for inspection. Its role is pivotal, as it helps regulate the engine's operations by ensuring that the engine runs at optimal temperatures, aiding in fuel efficiency and emissions control. When the circuit registers high voltage, typically seen as readings of 4.92 volts or more, or temperature readings around -40 degrees Fahrenheit or Celsius, this can indicate a faulty sensor, a wiring issue, or a failure in the ECM/PCM. Addressing the code P2185 involves investigating the connections and functionality of the ECT sensor, amongst other steps, to eliminate any potential faults that can lead to larger issues within the vehicle system. Several potential causes can lead to the setting of DTC P2185. The most common culprit is a faulty ECT sensor itself, which may fail internally, giving incorrect temperature readings or voltage levels. Additionally, wiring issues are another significant contributor. Frayed or damaged wires can cause intermittent or complete failure of the sensor's function. Poor electrical connections, particularly at the ECT sensor or the ECM/PCM connectors, can result in high resistance, leading to misleading voltage readings. Each of these causes reinforces the importance of correctly diagnosing the issue to avoid monetary and time wastage associated with random part replacements. Knowing the conditions that lead to this error increases the chances of identifying the true fault quickly and efficiently. When DTC P2185 is triggered, several symptoms can manifest within the Honda Civic. One major indicator is engine performance issues like rough idling, stalling, or hesitations during acceleration, all of which correlate closely with incorrect temperature readings. Drivers may also notice declining fuel economy, as the engine may use more fuel when it cannot effectively regulate temperature. The check engine light will typically illuminate on the dashboard, alerting the driver to the underlying problem. This code might not have immediate dramatic impacts on vehicle operations, but failing to address it can lead to more severe issues and expensive repairs in the long run. If you've noticed any of these symptoms alongside the illumination of the check engine light, it indicates that a thorough diagnostic of the ECT system is urgent. The first troubleshooting step in addressing DTC P2185 involves turning the ignition switch to the on/to position without starting the engine. At this point, using the Honda Diagnostic System, HDS, check the data for ECT Sensor 2. The readings observed should indicate a normal range. However, if the sensor reads -40 degrees Fahrenheit, -40 degrees Celsius, or higher than 4.92 volts, this suggests a fault in the sensor or its circuit. If the readings meet these criteria, proceed to the next steps. If the values are normal, it may suggest intermittent failure, meaning the system might be operational at that moment. But it's still essential to check for poor connections or loose terminals at the ECT sensor and ECM/PCM to ensure the fault isn't sporadic. For the second step in the troubleshooting process, turn the ignition switch to the lock 0 position. Once the ignition is off, proceed by disconnecting the ECT sensor 2 connector, which typically has a 2P configuration. This step is vital as it prepares the system for an internal inspection. After disconnecting, make sure to inspect the connector for any signs of corrosion, moisture, or damage that could affect the sensor's voltage readings. Be particularly vigilant about the connector pins. Any signs of wear or poor contact could indicate an underlying issue that requires repair or replacement. This step ensures that you can accurately assess the internal wiring connections of the ECT sensor itself and the general condition of the vehicle's electrical infrastructure leading to the sensor. The third troubleshooting step involves connecting the terminals of the ECT sensor 2P connector using a jumper wire. This connection should be made between terminal number 1 and terminal number 2. The purpose of this step is to create a direct pathway that simulates a normal sensor output. Once the jumper wire is in place, turn the ignition switch back to the on, second position, again, and revisit the HDS data list for ECT sensor 2 readings. If the readings now indicate -40 degrees Fahrenheit, -40 degrees Celsius, or 4.92 volts or more, the wiring remains suspect, leading us to the next steps. However, if the readings continue to indicate normal values, the sensor itself may be at fault, and further inspections should focus on testing the ECT sensor directly. In the fourth step, after taking note of previous readings, carefully remove the jumper wire from the ECT sensor 2P connector. Next, turn the ignition switch to the on 2 position once again. At this point, the focus will shift towards measuring the voltage at the ECT sensor 2's terminal number 2 in relation to the body ground. Utilizing a digital multimeter, perform this voltage measurement. This critical step will help to ascertain if voltage is being accurately transmitted from the sensor to the ECM/PCM. Normal readings should indicate that the sensor is working correctly and that the issue lies elsewhere, such as in the wiring or the computer systems. Highlighting any discrepancies in voltage outputs during this step can further lead towards the right component responsible for the DTC code. After successfully identifying and rectifying the issue leading to DTC P2185, it is essential to confirm that all repairs have been completed effectively. Start by clearing any DTC codes stored in the ECM/PCM to ensure that is reset and does not reflect previous errors. Following this, a test drive of the vehicle is necessary to monitor for performance and to check if the warning light reappears. During the test drive, observe engine temperature and performance metrics to validate that everything operates within normal ranges. By ensuring that the vehicle performs satisfactorily, you validate that the repair was indeed successful and that the issue has been resolved. Additionally, this step allows for the monitoring of other systems that could be indirectly affected during the initial problem. Preventive maintenance is crucial to avoid recurrence of DTC P2185 in the future. Regular checks of the ECT sensor can help identify early signs of wear or degradation, allowing for timely replacements before they lead to larger issues. Additionally, conducting routine inspections of wiring and connectors helps to catch any developing issues, exposed wires, or loose connections that could compromise the electrical signals. Keeping the connectors clean and free from corrosion is an essential step in maintaining reliable performance. Furthermore, ensuring that the vehicle's cooling system is well maintained can contribute to the sensor's proper functioning, as overheating can cause premature failure of associated components. Consistent attention to these aspects will significantly reduce the likelihood of facing similar error codes in the future. In summary, understanding DTC P2185 and its implications for your Honda Civic is essential for maintaining optimal vehicle performance. We've explored the significance of the ECT sensor, the potential causes of high voltage readings, and the symptoms that indicate a problem within this circuit. By methodically following the troubleshooting steps, you can identify the root cause of the error, whether it be at the sensor itself, wiring, or connections. Corrective actions taken promptly can prevent further complications and safeguard vehicle functionality. Regular preventive maintenance can go a long way in forestalling similar issues in the future, ensuring smooth operation of your engine coolant temperature monitoring system. Ultimately, timely diagnosis and repair can save both time and money while ensuring your vehicle runs reliably. Please like and subscribe to the channel. See you next time.